Namaskar, dear students, welcome. We are solving problems from the exercise section 2.1 of the book Differential Equations by Shepley L. Rose. Today we shall up to question number 15. We have solved up to question number 15. Up to question number 15, all the problems have been solved. Now, today I shall try to solve this problem. Question number 16. Suppose this equation is number 1. Question number 16, it is 1. Solve the initial value problem. This dx plus this dy equal to 0, y1 equal to 8. This is the initial value problem. We have to solve these differential equations. The differential equation 1 can be written as, x to the power minus 2 by 3, y to the power minus 1 by 3 plus 8x, it will be 1 by 3 y to the power 1 by 3 dx. This can be written as this, plus 2x to the power 4 by 3 y to the power minus 2 by 3 minus 2 by 3 minus x to the power 1 by 3 minus 4 by 3. What is x to the power 1 by 3? X to the power 1 by 3 y to the power minus 4 by 3. Minus 4 by 3 dy equal to 0. You may write like this. Now, if you compare this differential equation with mxy plus dx plus nxy dy equal to 0, comparing with m dx plus m dy equal to 0 and dy equal to 0, we get mxy. This m will be equal to x to the power minus 2 by 3 y to the power minus 1 by 3 plus 8 x to the power 1 by 3 y to the power 1 by 3, and mxy will be equal to 2 x to the power 4 by 3 y to the power minus 2 by 3 y to the power minus 2 by 3 minus x to the power 1 by 3 y to the power minus 4 by 3. You will get this one. Therefore, del m by del y. What is del m by del y? It will be minus 1 by 3. X to the power minus 2 by 3 y to the power minus 4 by 3. Differentiate partially with respect to y, treating x as constant, plus 8 into 1 by 3 x to the power 1 by 3 y to the power 1 by 3 minus 1 means minus 2 by 3. Minus 2 by 3, you will get this. And del n by del x, you will get 2 into 4 by 3 x to the power 1 by 3 y to the power minus 2 by 3 minus 1 by 3 x to the power minus 2 by 3 y to the power minus 4 by 3. You will get this one. You will get this one. This means del m by del y equal to minus 1 by 3 x to the power minus 2 by 3 y to the power minus 4 by 3 plus 8 by 3 x to the power 1 by 3 y to the power minus 2 by 3, and del n by del x, this is equal to 8 by 3 x to the power 1 by 3 y to the power minus 2 by 3 minus 1 by 3 x to the power minus 2 by 3 y to the power minus 4 by 3. You see this one. Now, therefore, del m by del y, del m by del y, this is equal to del n by del x. Del n by del x, del m by del y equal to del m by del x. Therefore, the given differential equation is exact. Therefore, 1 is exact. Therefore, 1 is exact. What does it mean? Since 1 is exact, there exists a function u such that m dx plus n dy equal to u. This means there exists a function u of xy such that m dx plus n dy, this is equal to du, and m dx plus n dy equal to du. This means this is m. This means m means this one, x to the power minus 2 by 3 y to the power minus 1 by 3 plus 8 x to the power 1 by 3 y to the power 1 by 3, this dx plus 2 times of x to the power 4 by 3 y to the power minus 2 by 3 minus x to the power 1 by 3 y to the power minus 4 by 3 dy. This is equal to del u by del x dx plus del u by del y by del y dy. This means this one. You will get this one. This means that del u by del x, this is equal to x to the power minus 2 by 3 plus 8 x to the power 1 by 3 y to the power 1 by 3. Suppose this is number 2, del u by del y, this is equal to this one 2 times of x to the power 4 by 3 y to the power minus 2 by 3 minus x to the power 1 by 3 y to the power minus 4 by 3. Suppose this is number 3. This is 2 and this is number 3. Now from 2 uxy will be equal to integral x to the power minus 2 by 3 minus 2 by 3 y to the power minus 1 by 3. It should have been x to the power 1 by 3 minus x to the power minus 2 by 3 y to the power minus 1 by 3. Yes, x to the power minus 2 by 3 y to the power minus 1 by 3 plus 8x to the power 1 by 3 y to the power 1 by 3 integrate with respect to x, treating it is 3 y to the power 1 by 3 plus pi y, you will get this one. This means that This means that uxy, this is equal to, with respect to x, integrate treating y as constant, y to the power minus 1 by 3 is there, x to the power minus 2 by 3 plus 1 divided by minus 2 by 3 plus 1. This will be equal to x to the power 1 by 3 by 1 by 3, x to the power 1 by 3 divided by 1 by 3, y to the power minus 1 by 3 plus 8, x to the power 2 by 1 by 3 plus 1, 4 by 3 divided by 4 by 3, y to the power 1 by 3 plus 5y, you will get this one. This is equal to 3 x to the power 1 by 3 y to the power minus 1 by 3 plus, it will be 2 by 3 x to the power 4 by 3 y to the power 1 by 3 plus 5y. Uxy will be equal to this. Suppose this is number 4. From 4 implies del u by del y. With respect to y, 3 into minus 1 by 3, 3 minus 1 by 3 x to the power 1 by 3, y to the power minus 4 by 3 plus 2 by 3 into 1 by 3 not number 1. This for 2, it will be 6. This will be 6. This will be 6. Six into 1 by 3 x to the power 4 by 3 y to the power 1 by 3 minus 1 means minus 2 by 3 plus d phi by dy. This means del u by del y, this is equal to minus x to the power 1 by 3 y to the power minus 4 by 3 plus 2 x to the power 4 by 3 y to the power minus 2 by 3 plus d phi by dy. Suppose this is number 5. This is the. Now compare to 3 and 5. Both are del u by del y. From 3 and 5 we get Now from 5 you write x to the power 1 by 3 y to the power minus 4 by 3 plus 2 times of x to the power 4 by 3 y to the power minus 2 by 3 plus d phi by dy equal to, from 3 you write 2 times of 2 x to the power 4 by 3 y to the power minus 2 by 3 minus x to the power 1 by 3 y to the power minus 4 by 3. Now these two terms will be cancelled. These two terms will be cancelled, and also these two terms also will be cancelled. This means that dy by dy equal to 0. This means phi y equal to constant. C naught, this is equal to constant. Phi y equal to constant. Therefore, you will get phi y equal to constant. Now, the solution of the differential equation is, since it is exact, m dx plus m dy equal to du. M dx plus m dy equal to 0 means du equal to 0 means u, which is a function of x and y, is constant. The solution of the differential equation is u xy equal to constant. Solution of the differential equation is solution of the differential equation is, given differential equation is u xy equal to c1 equal to constant. This is equal to constant. Cxy equal to constant. Therefore, 4 implies, therefore from 4 you will get uxy equal to 3 x to the power 1 by 3 y to the power minus 1 by 3 plus 6 x to the power 4 by 3 y to the power 1 by 3 plus c naught equal to c1. This means 3x to the power 1 by 3 y to the power minus 1 by 3 plus 6 x to the power 4 by 3 y to the power 1 by 3 equal to thrice c, where thrice c equal to, thrice c is equal to c1 minus c naught. C1 minus c1 c naught equal to thrice c. This means that this means x to the power 1 by 3 y to the power minus 1 by 3 plus 2 times of x to the power 4 by 3 y to the power 1 by 3 is equal to c. This is the solution of the given differential equation. X to the power 1 by 3 y to the power minus 1 by 3, and this is the solution of the given differential equation. We have solved this equation by one method. Let us try to solve this equation by method 2. By method 2. The given differential equation is this. This is 1. We have solved this, but we have not applied the initial condition y1 equal to 8. After solving this problem by 3 methods, we shall apply the initial condition. Now 1 means, what is 1? 1 means x to the power minus 2 by 3 y to the power minus 1 by 3 plus 8 x to the power 1 by 3 y to the power 1 by 3 dx plus 2 times of x to the power 4 by 3 y to the power minus 2 by 3 minus x to the power 1 by 3 y to the power minus 4 by 3 dy equal to 0. The solution of the differential equation is integral, since it is exact, integral m dx treating y as constant plus integral m dy taking only those terms which are free from x. Solution of 1 is integral m dx x to the power minus 2 by 3 y to the power minus 1 by 3 plus 8 x to the power 1 by 3 y to the power 1 by 3 del x. Means integrate this treating y as constant plus taking only those terms in y in n which do not contain x. No, this contains x, this contains x. Therefore, no term is there. dy equal to constant. Now integrate this one. This means it will be x to the power minus 2 by 3 plus 1. Means 1 by 3 divided by 1 by 3. Y to the power minus 1 by 3 plus 8. X to the power 4 by 3 divided by 4 by 3. Y to the power 1 by 3. This is equal to, suppose this is thrice c. This means 3 times of x to the power 1 by 3, y to the power minus 1 by 3 plus it will be 6, x to the power 4 by 3, y to the power 1 by 3. This is equal to thrice c. Thrice c is constant. This is constant. Arbitrary constant. This means x to the power 1 by 3, y to the power minus 1 by 3 plus 2 times of x to the power 4 by 3, y to the power 1 by 3 equal to c. This is the solution of the given differential equation. Now, previously also, x to the power 1 by 3, y to the power minus 1 by 3. 1 by 3, y to the power minus 1 by 3, twice x to the power 4 by 3, y to the power 1 by 3. This is the solution of the differential equation. So far, we have solved this equation, differential equations by two methods. Let us try to solve this equation by method 3, which is the method of grouping method. The grouping method. This is number 1. This means grouping method of grouping. X to the power minus 2 by 3, y to the power minus 1 by 3 plus 8. X to the power 1 by 3, y to the power 1 by 3 dx plus 2 times of x to the power 4 by 3, y to the power minus 2 by 3 minus x to the power 1 by 3, y to the power minus 4 by 3 dy equal to 0. Grouping method. Grouping method. Grouping method. This means x to the power minus 2 by 3, y to the power minus 1 by 3 dx. 1 by 3. Now take this with this one. Minus x to the power 1 by 3, y to the power minus 4 by 3 dy. Group this one. Plus 8 x to the power 1 by 3, y to the power 1 by 3 dx plus 2 times of x to the power 4 by 3, y to the power minus 2 by 3 dy. This group, this two, like this. This means that y to the power minus 1 by 3, x to the power minus 2 by 3 dx minus x to the power 1 by 3, y to the power minus 4 by 3 dy. You may write like this. You may write like this plus you may common 2, 4 y to the power 1 by 3, x to the power 1 by 3 dx plus x to the power 4 by 3, y to the power minus 2 by 3 dy. This is equal to 0. You may write like this. You may write like this. This means y to the power minus 1 by 3, thus integrate this x to the power minus 2 by 3, x to the power minus 2 by 3 plus 1 divided by minus, x to the power 1 by 3 by 1 by 3. You may write here d of x to the power 1 by 3 divided by 1 by 3. minus x to the power 1 by 3. It will be y to the power minus 1 by 3 divided by minus 1 by 3 d of. You may write like this, d of this, plus 2 times of 4y to the power 1 by 3 d of x to the power 4 by 3 divided by 4 by 3. You may write like this, plus x to the power 4 by 3 d of x to the power d of y to the power 1 by 3 y to the power 1 by 3 divided by 1 by 3. You may write like this, equal to 0. This is equal to 0. This means that this is grouping. It will be 3. It will be minus minus plus 3. You will get 3 y to the power 1 minus 1 by 3 d of x to the power 1 by 3 plus x to the power 1 by 3 d of y to the power minus 1 by 3 plus 2 times of 4 will be cancelled. This 3 also 3 times of y to the power 1 by 3 d of x to the power 4 by 3 plus again 3 times of x to the power 4 by 3 d of y to the power 1 by 3. This is equal to 0. This is equal to 0. Or 3 times of the first function into differentiation of the second function plus second function differentiation of the first function. X to the power 1 by 3 y to the power minus 1 by 3 plus it will be 6 3 first function differentiation of the second function. You may write here x to the power 4 by 3 y to the power 1 by 3. This is equal to 0. This is equal to 0. This means d of x to the power 1 by 3 y to the power minus 1 by 3 plus 2 times of x to the power 4 by 3 y to the power 1 by 3. This is equal to 0. Integrating we get x to the power 1 by 3 y to the power minus 1 by 3 plus 2 times of x to the power 4 by 3 y to the power 1 by 3. This is equal to constant. This is equal to constant. Previously also we got x to the power 1 by 3 y to the power minus 1 by 3 to x to the power 4 by 3 y to the power 1 by 3. Given that y1 equal to 8, that is y is equal to y is equal to 8 when x is equal to 1. Put here x is equal to 1 to the power 1 by 3. Y means 8 to the power minus 1 by 3 plus 2 1 to the power 4 by 3 8 to the power 1 by 3 equal to C. This means 8 to the power minus 1 by 3 means 2 cube, 2 to the power minus 1, 2 to the power minus 1 plus 2 into 2 equal to C. This means 2 plus 4, the 1 by 2 plus 4, 1 by 2 plus 4. This means 1 by 2 plus 4 equal to C. This means 9 by 2 equal to C. 9 by 2 equal to C. Therefore, suppose this, therefore solution is, final solution Final solution is, therefore final solution is x to the power 1 by 3, y to the power minus 1 by 3, 2x to the power 4 by 3, y to the power 1 by 3. This is equal to 9 by 2. This is equal to 9 by 2. Am I right? 2 to the power 2 to the power minus 1, 1 by 2, it will be 1, y equal to 8 means this will be 2, already 2 is there, 4, 9 by 2. This is the final answer of the given differential equation. Therefore, we have solved question number 16. Let us try to solve the question number 17. What is this? In each of the following equations, determine the constant A such that the equation is exact and solve the resulting exact equation. 17A, 17B. 17A is this, 17. First, we shall find the value of A, and then we shall solve the exact differential equation. Exact differential equation. Let me first solve the question number 17. Suppose this is number 1. 1 is exact. 1 is exact. It is given that 1 is exact. Therefore, del, it is of the form m dx plus m dy equal to del y of x square plus thrice xy equal to del x of ax square plus 4y. This means thrice x equal to, it will be twice ax. Twice ax. This means 3 equal to twice a. This means a equal to 3 by 2. A is equal to 3 by 2. Putting a is equal to 3 by 2. A equal to 3 by 2 in 1. You will get x square plus thrice xy dx plus 3 by 2 x square plus 4y dy equal to 0. Suppose this is number 2. For 2, mxy equal to x square plus thrice xy n equal to 3 by 2 n means nxy equal to 3 by 2 x square plus 4y del m by del y equal to thrice x. Here del n by del x equal to 3 by 2 into twice x equal to thrice x. Thus del m by del y equal to del n by del x. Therefore 2 is exact. Therefore 2 is exact. Two is exact. Two is exact. This means that there exists a function u x y such that m dx plus m dy equal to du. This means that x square plus thrice xy dx plus 3 by 2 x square plus 4y dy, this is equal to du. Du means this is equal to, I am writing here, del u by del x dx plus del u by del y dy. Del u by del y dy. You will get this one. This means that del u xy by del x equal to x square plus thrice xy. Suppose this is number 3. Del u by del y equal to 3 by 2 x square plus 4y. X square plus 4y. This is number 4. This is number 4. From 3 implies, from 3 you will get uxy will be equal to integral x square plus thrice xy, treating y as constant, plus a function phi y. This is equal to x cubed by 3 plus 3 by 2 with respect to x square by 2 y plus phi y. This is number 5. From 3 integrate this. This is number 5. uxy equal to this. Suppose this is number 5. This means that five implies del u by del y will be equal to, it will be 0 with respect to y, means it will be 3 by 2 x square plus d phi y by dy, d phi y by dy. It will be number 6. Now, from 4 and 6, both are del u by del y, del u by del y. 4 and 6, from 4 and 6. 4 and 6. 3 by 2 x square plus d phi y by dy. This is equal to 3 by 2 x square plus 4y. This means d phi y by dy equal to 4y. This means phi y will be equal to twice y square plus the constant of integration. Constant of integration. The solution of the differential equation. The solution of the differential equation is, solution of 2 is, the differential equation is uxy equal to constant. Uxy equal to constant. This means from 5, therefore from 5, the solution is x cubed by 3 plus 3 by 2 x square y plus phi y means twice y square plus c naught equal to c1. C naught equal to c1. Or x cubed by 3 plus 3 by 2 x square y plus twice y square equal to c divided by 6, where c by 6 equal to c1 minus c naught. This means multiply both sides by 6. You will get twice x cube plus 9x square y plus 12y square equal to c. This is the solution of the given differential equation. This is the solution of the given differential equation. Twice x cube plus 9x square y plus 12y square equal to c. We have solved this equation by method 1. Let us try to solve this equation by method 2. By method 2. A equal to, we got A equal to 3 by 2. A equal to 3 by 2. The differential equation is this. Putting A equal to 3 by 2. A equal to 3 by 2. The differential equation becomes x square plus thrice xy dx plus 3 by 2 x square plus 4y dy equal to 0. 4y dy equal to 0. Solution is, what is this? Solution is integral m dx treating y as constant plus integrate m dy taking only those terms which do not contain y. This is equal to constant. This means you will get constant with c by 6. You may write c by 6. X cube by 3 plus 3 by 2 x square y plus, this means twice y square is equal to c by 6, or you may write multiply both sides by 6. 2x cube plus 9x square y plus 12y square equal to c. This is the solution of the given differential equation 17a. This is equal to c. We have solved this equation by two methods. Now method 3, grouping methods. Method 3. In examinations, you should apply only one method. But for your convenience, I am solving by 3 different methods. Method 3, grouping method. Now this is one implies this equation is suppose star implies the given differential equation is this: x square plus thrice xy dx plus 3 by 2 x square plus 4y dy. Group this x square dx, no problem here. Now x square dx thrice xy dx plus 3 by 2 x square dy, group this, plus 4y dy equal to 0. You may write like this. Now this means d of, you may write x cube by 3 plus, you may write y thrice y, x dx means d of x square by 2 plus 3 times of x square by 2 d of y plus d of twice y square equal to 0. You may write like this. Now this means d of x cube by 3 plus 3 common, you may write d of x square by 2 into y plus d of twice y square equal to 0. Or you may write d of x cube by 3 plus 3 by 2 x square y plus twice y square equal to c, equal to 0. Integrating, you will get x cube by 3 plus 3 by 2, x cube by 3 plus 3 by 2 x square y plus twice y square equal to c by 6. C by 6. Now, after that I am writing here. This means multiply by 6 twice x cube plus 9x square y plus 12y square equal to c. 12y square equal to c. This is the solution. After this, I am writing here. This is the solution of the differential equation. Therefore, 17a has been done by 3 different methods. Now, let us come to solve question number 17b. 17b. Suppose this is 1, 17b. 1 is exact. 1 is exact. Therefore, del y of 1 by x square plus 1 by y square equal to del x of ax plus 1 divided by y cube. You will get this one. This means with respect to y, differentiate minus 2 by y cube. Minus 2 by y cube. This is equal to a by y cube. This means a equal to minus 2. Answer, this is a is equal to minus. Find the value of a. A is equal to minus 2. Therefore, putting a equal to minus 2 in 1. Putting a equal to minus 2. Putting a equal to minus 2. Minus 2 in 1. 1 by x square plus 1 by y square dx plus minus twice x plus 1 by y cube dy equal to 0. Suppose this is number 2. For 2, mxy equal to xy equal to 1 by x square plus 1 by y square, mxy equal to minus twice x plus 1 by y cube. Del m by del y, I am writing here, del m by del y. With respect to y, x is constant, minus 2 by y cube. Del n by del x, del n by del x, del n by del x. What is del n by del x? Now, it will be y cube is constant, minus 2 by y cube. Therefore, for 2, del m by del y equal to del n by del x. Del n by del x. Therefore, 2 is exact. 2 is exact. Since 2 is exact, this means there exists a function u of x, y such that m dx plus m dy plus m dy equal to du. M dx plus m dy equal to du. M dx plus m dy equal to du. M dx plus m dy equal to du. This means that after this, I am writing here. M dx plus m dy equal to du. This is du. This is du. This means that what is m? M means this 1 by x square plus 1 by y square dx plus minus twice x plus 1 by y cube dy equal to del u by del x dx plus del u by del y dy. This means that del u by del y del x equal to 1 by x square plus 1 by y square. 1 by x square plus 1 by y square. This is number 3. del u by del y, this is equal to minus twice x plus 1 divided by y cube. This is number 4. This is number 4. From 3, uxy equal to integral 1 by x square plus 1 by y square del x plus phi y, del x plus phi y. This means uxy equal to, with respect to x to the power minus 2, the integration is x to the power minus 1 divided by minus 1 plus 1 by y square x plus phi y. This means that uxy equal to minus 1 by x plus x by y square plus phi y. Suppose this is number 5. This is number 5. Del u by del y, it will be constant minus twice x divided by y cube plus d phi by dy. Suppose this is number 6. From 4 and 6, we get minus twice x by y cube plus d phi y by dy equal to, it can be written as minus twice x by y cube plus 1 by y cube. You may write like this, or d phi by dy equal to 1 by y cube. This means phi y equal to, integrate this, y to the power minus 3. The integration of y to the power minus 3 is y to the power minus 2 divided by minus 2. Minus 2 divided by minus 2 plus c naught. I am writing here. This means phi y equal to minus 1 by twice y square plus c naught. Therefore, put the value of phi y in 5, we will get uxy equal to minus 1 by x plus x by y square plus x by y square minus 1 by twice y square plus c naught. Solution of the differential equation is uxy equal to constant c1. Therefore, minus 1 by x plus x by y square minus 1 by twice y square plus c naught equal to c1. Or you may write minus 1 by x plus x by y square minus 1 by twice y square equal to c divided by 2, where c by 2 equal to c1 minus c naught. This means that after that I am writing here, multiply both sides by twice x y square minus twice y square plus twice x square minus x, this is equal to c xy square. Am I right? Twice x square minus twice y square. Therefore, or you may write twice x square. You may write twice x square minus twice y square minus x equal to cx y square. Cx y square. Twice x square minus twice y square minus x equal to cx y square. Cx y square. We have solved this equation by method 1. Let us try to solve this equation by method 2. By method 2 and 3. This is 1. A equal to minus 2. A is equal to minus 2. A equal to minus 2. 1 becomes 1 by x square plus 1 by y square dx plus minus twice x plus 1 by y cube dy equal to 0. It is exact. A is equal to minus 2. It is exact. Since it is exact, therefore its solution is integral. Its solution is integral m dx, treating y as constant, plus integrate m dy, taking only those terms which are free from x. It will be 1 by y cube dy, because this can be written as minus twice x by y cube plus 1 by y cube. This term contains x, but this term does not contain x. Therefore, this is equal to constant. Let me write c by 2. Therefore, you will get x to the power minus 1 by minus 1 plus x by y square plus y to the power minus 2 divided by minus 2 equal to c by 2. This means minus 1 by x plus x by y square minus 1 by twice y square equal to c by 2, or minus twice y square plus twice x square minus x equal to cx y square, multiplying both sides by twice x y square. This is equal to this is the answer. We have solved this equation. 1 by x square plus 1 by y square dx equal to this one. Let us try to solve this equation by another method, by the method number 3. Number 1 is 1 by x square plus 1 by y square dx plus ax, you see, ax plus 1 by y cube, ax plus 1 by y cube, ax plus 1 by y cube dy equal to 0, y equal to, here a equal to minus 2, a is equal to minus 2. A is equal to minus 2. The equation becomes, putting a equal to minus 2, equation becomes, putting a equal to minus 2, the equation becomes 1 by x square plus 1 by y square dx plus minus twice x plus 1 by y cube dy equal to 0. This means grouping method 1 by y square dx minus twice x by y cube dy, group this one, plus 1 by y cube dy, 1 by y cube dy. This means d of x to the power minus 1 by minus 1. Minus 1. You may write like this, or you may write d of direct d of minus 1 by x. It will be 1 by x square dx plus 1 by y square dx plus x d of 1 by y square. You may write like this, because if you differentiate this, minus twice y to the power minus 3 dy minus 2 y to the power minus 3 dy plus d of minus 1 by twice y square. You may write like this. You may write like this. Y to the power minus 2, integration is, differentiation is minus 2, y to the power minus 3. Minus 2 will be cancelled. It will be this. Or this means d of minus 1 by x plus, it can be written as d of x by y square plus d of minus 1 by twice y square equal to 0. Or you may write d of minus 1 by x plus x by y square minus 1 by twice y square equal to 0. Integrating, we get minus 1 by x plus x by y square, it is minus 1 by twice y square equal to, suppose, c by 2. Or you may write minus twice y square plus twice x square minus x equal to cx y square, or twice x square plus twice x square minus twice y square minus twice y square minus x cx y square. This is the solution of this. Therefore, we have solved question number 17b in 3 methods. Question number 17a also has been done by 3 methods. Question number 16 also has been done by 3 methods. Therefore, I shall not continue today. In the next class, we shall solve question number 18, 19, 20, like that. And today I want to stop here. Thanks for attending the class. Thank you very much. Namaskar. Thank you very much.